Hello everyone, this is Mr. Mohammed Hussein from Al Noon International School, your grade 10 algebra teacher. Welcome to week 15, chapter 13, lesson 6, the tangent function. Here are the objectives of the lesson: to graph the tangent function, to find the period and asymptotes of the tangent function. The function y is equals to tan theta is the ratio of sine to cos theta. Since the coordinate xy equals cos theta, sine theta, tan theta is defined as the ratio of sine to cos theta, or y over x. Look at this graph. This represents the graph of tan function of one cycle. These broken lines to the left and to the right represent the asymptote of the graph. And this point or this line will never be crossed by the graph of tan function since they are asymptotes. And look at this graph at the right. Still, this graph represents the graph of y is equals to tan theta with different cycles, or 5 cycles. 1, 2, 3, 4, 5 cycles. Still we have asymptotes. Or the point at which the graph will not cross. So these broken lines are called asymptotes of the graph. And you can draw the graph of y is equals to tan theta either by using the radian measures or degree measures. Now let us see some key concepts of the lesson. Suppose y is equals to a times tan b theta, with a different from 0, b greater than 0, and theta is in radian. So number 1, pi over b is the period of the function. Unlike the sine and the cosine function, the period was 2 pi over b, but the period for the tan function is pi over b. One cycle occurs in the interval from negative pi over 2b to pi over 2b. There are vertical asymptotes at each end of the cycle. An asymptote is the point at which tan theta cannot be defined. These points include plus or minus pi over 2, plus or minus 3 pi over 2, plus or minus 5 pi over 2, or as you can observe, it is the multiples of what? Pi over 2. Plus or minus 1, plus or minus 3 times pi over 2, plus or minus 5, and then plus or minus 7 times pi over 2, and so on. So these points are the asymptote, or the point at which the graph will not cross. The graph of tan theta has no amplitude, unlike sine and the cosine function. Now let us see some examples. Example number 1, or problem number 1. What is the value of each expression? Do not use calculator. A tan pi, b tan negative pi over 6. And the givens are here, depending on these givens. Part A, tan pi means the angle which is measured from this point, positive x-axis, to this point is pi, or its semicircle, which is 180, or pi. So what is tan of pi? And again, from the second figure, the angle is measured clockwise direction from positive x-axis to this point, and it's negative 5 pi over 6, and its coordinate is negative root 3 over 2 and negative 1 over 2. So how can you find tan negative 5 pi over 6 without using calculator? We know that tan pi is y over x, as tan is defined as the ratio of sine to cosine. Sine is y, cos is x. So sine over cos is y over x, which means you just use or pick the point or the coordinates from here. The value of y here is 0 and the value of x is negative 1. So 0 over 1 is 0. Here again, tan negative 5 pi over 6 equals y over x, which is y negative 1 over 2 divided by negative root 3 over 2, which gives you root 3 over 3. So tan of negative 5 pi over 6 is equal to positive root 3 over 3. Example number 2, graphing a tangent function. Sketch 2 cycles of the graph of y is equal to tan pi theta. In this part, firstly, we have about 3 steps. The first one, or step 1, find the x-intercept of the graph. X-intercept of the graph. Where does the graph cross the x-axis? How can I find this? You just put y is equal to 0 to find x-intercept. As usual, when you are looking for x-intercept, always make y is equal to 0. That means the equation y is equal to tan pi theta is the same as sine pi theta over cos pi theta, which is the ratio of the sine and cosine, which is equal to y over x. Then think when sine pi theta is equal to 0. When sine pi theta is equal to 0, because you put y equal to 0. And take the inverse, sine inverse of this equation. So pi theta equal to sine inverse of 0. Pi theta is equal to sine inverse of 0. And which angles have sine value 0? Which angles have sine value 0? So the angles like 0, pi, 2 pi, 3 pi, 4 pi have sine value 0. So the inverse of sine inverse of 0 are 0, pi, 2 pi, 3 pi, 4 pi, and so on. So put pi theta equals n pi, where n is 0, 1, 2, 3, 4, and so on. Then solve for theta, solve for theta for each values over here. For example, the first one, pi theta equal to 0, so theta equal to 0. Pi theta is equal to pi, so theta is equal to 1. Pi theta equals to 2 pi, then theta is equal to 2. Pi theta is equal to 3 pi, so theta is equal to 3, and so on. So these are x-intercepts of the graph, or the point at which the graph crosses the x-axis. Step number 2, find asymptotes. Find asymptotes. The point at which the graph is undefined. The point at which the graph is undefined. How can you find these asymptotes? Think again about this equation or expression. Sine pi theta over cos pi theta will be undefined when the down cos pi theta is 0, because sine pi theta over 0 will be undefined. So put cos pi theta equal to 0, because it will be undefined when cos pi theta equal to 0, which means cos pi theta equal to 0. The graph is undefined. Then take the cos inverse. Take the cos inverse of this equation. So pi theta is equal to cos inverse of 0. Again, think which angles have cos value 0. It's like pi over 2, 90, 3 pi over 2, 270, and so on, 540. Then solve the equation for each values. For example, for the first one, pi theta is equal to pi over 2, so theta equals 1 over 2. Again, pi theta equal to 3 pi over 2, so theta is equal to 3 over 2. And pi theta is equal to 5 pi over 2, it is theta will be 5 over 2. So 1 over 2, 3 over 2, 5 over 2 are the asymptotes, or the point at which the graph will not cross. The graph will not cross. So using these facts, step 1, step 2, once you have the x-intercepts and the asymptotes, put these numbers in order, mix up this and this in order, which means 0, 1 over 2, then 1, 3 over 2, then 2, 5 over 2, 3, and so on. Put in order like this: 0, 1 over 2, 1, 3 over 2, 2, 5 over 2. So just draw the graph since the shape of the graph of time function is always like this. The first x-intercept is 0, the second x-intercept is 1, as you can see. Look at these yellow graphs or lines. Then the other one is 3, the other one is 2, and the next will be 3 here. But these blue lines shows the asymptotes, because 1 over 2, 3 over 2, 5 over 2 are asymptotes. These are asymptotes. The blue lines shows asymptote. Then the yellow line, which is drawn always like this, is the graph of y is equals to tan pi theta.